All right, today we are going to start talking about polynomials and specifically the leading coefficient test. And when you hear the word polynomial, a lot of times it sounds like a big fancy word that, what is it? So let's start by defining it. What is a polynomial? Well, it's a function and our most familiar polynomial is a quadratic. All right, a quadratic is a polynomial, something like x squared minus 2x minus 35. That's a polynomial. That's an example of a polynomial. You'll notice that we have a decreasing power of x, all right, and we often have a constant number at the end, okay? But obviously this is not the only type of polynomial. We could have one that starts with a cubic, starts with something cubed. We could have one that starts with something to the fourth power, or to the fifth power, all right? So the general form of a polynomial is much uglier. Here it is. A, x to the n plus b, x to the n minus 1 plus c, x to the n minus 2 plus on down to dx plus k. And I know that looks really ugly, but it is essentially saying the same thing as this quadratic up above. Look, we can match this up. The a is the number in front of x squared. Here's my power, x squared, and then the next power is 1 less than that. All right? And then the next one is 1 less than that. On down to a number that just has an x in it. Here we go. Here's our dx. And then a constant, the k. All right? So, for example, let me give you an uglier polynomial that matches up to this form. How about 5x to the fourth plus 3x to the third minus 2x squared plus 5x minus 14? There's a big, long, honking polynomial for you. But it matches up our general form. All right? Notice, in a polynomial, the x is never in the denominator. Okay? If the x is in the denominator, it is not a polynomial. All right? Now, let's see what we're going to do with this today. We're going to talk some about whether a polynomial is continuous or not. If a polynomial is continuous, it does not have any breaks. There are no splits or cuts in it. If it is not continuous, it's probably going to be a piecewise function. We have talked about piecewise functions, ones that are defined in pieces. Maybe this function is, like x plus 1, and this function over here is x minus 2 quantity squared or something like that, and it's broken up as a piecewise function. That one would not be continuous. So just to kind of I just wanted to introduce the idea of a continuous function versus one that's not. But what we're going to do a lot with today is we are going to analyze a polynomial function using the leading coefficient test. It's pretty easy. the leading coefficient test. And there are basically two rules, all right? One dealing with when the highest power is odd, and one dealing with when the highest power is even, okay? So, first rule, rule number one. When the highest power is odd, there are two little substatements. A, if the leading coefficient, I'm just putting LC to save us some time in our notes. If the leading coefficient is positive, then the graph falls to the left and rises to the right. If the leading coefficient is positive, then the graph falls to the left and rises to the right. What are we saying here? If I have a function like this, 3x cubed plus whatever, 5x squared minus 7x plus 9. And I just made this function up. I'm not sure exactly what its graph looks like. But this is the leading coefficient. All right? And the highest power is odd. All right? The highest power is odd. So I know that this function is going to fall to the left and rise to the right. Now, I'm not real sure what it's going to do here in the middle. But it is going to go down to the left and up to the right. All right? And we could verify that with the graphing calculator. Okay? The other rule is if the leading coefficient is negative, it's the exact opposite. All right, so we'll say letter B, if the LC, if the leading coefficient is negative, it rises to the left and falls to the right. Rises to the left and falls to the right. This is if the highest power is odd. All right, so I know that in this case, my graph is going to do something like that. It's going to rise to the left and fall to the right. The leading coefficient predicts that for us. That's if the highest power is odd. Now, if the highest power is even, so this is rule 2. If the highest power is even, it's much easier. Rule A, if the leading coefficient is positive, it rises to the left and right. And if the leading coefficient is negative, it falls to the left and right. This was supposed to be an it up here, not an if. So if the leading coefficient is positive, the graph is going to go up both to the left and right. This is if the leading coefficient is positive. If the leading coefficient is negative, and we've learned this from our work with quadratics, if the leading coefficient is negative, it's going to fall to the left and to the right. All this information we get from the leading coefficient test. All right, so in your assignment tonight, they're going to give you a function, and they're going to ask you to describe the behavior of it, the left and right behavior. They're going to say, describe the left and right behavior of the graph. Let's say that my function is negative x cubed plus 4x. Well, all we have to do is follow the rules. The highest power is odd. Okay? Highest power, and you can just say n if you want. Highest power is odd. Leading coefficient is negative. So in this case, it rises to the left and falls to the right. And you can confirm that with your graphing calculator. All right? The leading coefficient is negative, and the highest power is odd. So this one, we're not sure what all it does in between, but we do know that it rises to the left and falls to the right. Okay? And then they're going to ask you to also do this problem. And I'm not going to make you write down the big long instructions for this problem, but they're going to give you two functions. This actually serves a purpose as you move into calculus. They're going to give you two functions like this, and they're going to ask you to use the graphing calculator to zoom out and show that these two functions look a lot alike. Okay? So when you're on a small window, you'll notice some differences. You know, F is maybe looking like this. Here's F. And G is kind of looking like this. But when you use a big window, they both wind up looking very, very similar when you zoom out. And that's the idea, is that you make your window larger on the graphing calculator. See if this will fit into our window here that I set up for our video recording. Negative x cubed plus 4x, negative x cubed, get down off the exponent, there we go, plus 4x, and then just regular old negative x cubed. If you do this on a standard window, you're going to see that they look different. All right? But if you change your window out, even just to, let's say, negative 30 to positive 30, we'll go up by 5s. And same thing on the y's. You don't have to go out very far. As a matter of fact, if you go too far, you won't see much. Do you see it? They're starting to look very much alike. All right? And the farther out that you change the x's especially, they will look more and more alike. Negative 50 to 50. Let's see what they look like now. You see that they're starting to look very much alike. All right, so polynomials have this tendency. Polynomials definitely have a tendency to look very much alike when you get zoomed out to a